Everyone, welcome to another video. Today we're going to be looking at what the derivatives of the log ex function are. Just a quick note here that what we're talking about today is when we have a log e function. Okay, so this course, when I say this course, but we're not going to do log base 2 of x or log base 10 of x or anything like that. We're only covering log base e of x, which turns out to be something quite nice. Okay, so we're only covering log base e. So if you're asked to find the derivative of something else, it's a much more complicated method and procedure. Well, not heaps more, but it's not what we're covering today. Okay, so just quickly, if you've got log ex, the derivative of log ex is something really nice. It's just 1 over x. Okay, so it's beautiful. The proof of that will be somewhere else. But just for today, I'm just showing you how to find derivatives. So the derivative is just 1 over x, which is lovely. Okay, now if you have a function inside the log e function, so function within a function, it's the chain rule again. And so what that means is it's 1 over g of x. Okay, so 1 over whatever's inside of there. So just like 1 over x, but instead you put the g of x. But because it's chain rule, we then need to multiply that by g dashed of x. Okay, just like any other function with the chain rule. That's how we sort of go about finding the derivative when we've got a function inside of the log e function. Okay, it's going to be a short video today. Let's get quickly to having a look at some examples. So we've got y equals negative 5 log e 7x. So let's have a look at dy dx. Let's find the derivative of this. That negative 5 will just sit out the front. And then we've got log e 7x. So we have got a function within a function, kind of. Okay, so I'll just put a bracket here so I can see what happens with that. There's negative 5 just sits there, remember? So what it's going to be is it's 1 over the function there, and our function today is 7x, or this question is 7x, that's going to be 1 over 7x, and then we need to multiply by the derivative of the inside function. The derivative of 7x is just 7, and so that's everything I need to do. I just need to clean it up a little bit, and that should be really easy. You'll see that, I'll just quickly show you this, that 7 will cancel out with that 7, and so that's really nice. And so you're just left with negative 5 over x. And in fact, this always happens with log e kx. You'll see that the derivative of that, so you know you've got that, the derivative of that is equal to 1 over kx. Well, I'm just saying k is any real number, and then multiplied by k. That k will always fill that. So the derivative of log e kx is always just 1 over x. So that's just a little shortcut there. But for the answer for today, negative 5 over x is all I need to do. Done. Fantastic. Let's have a look at this second one. We've got y equals negative 1/4 log e 1 over root x. Just whenever things are square roots, just always nicer to write it as a power when we're doing derivatives, and later when we do integrals and things, much nicer. So log e, I'm going to write this as x to the power negative 1/2. Okay, so much nicer now. We can sort of deal with that. Let's do this now. So therefore, our derivative, and we say we've got a function inside of the log e function. So I'm just going to write the negative 1/4 there. It sits there. And then what we've got is it's going to be 1 over the function. We write it there. So it'll be x to the negative 1/2. Okay. So 1 over that function. And then we're going to multiply by the derivative of that inside function. Okay. What's the derivative of x to the power negative 1/2? The negative 1/2 comes down the front. X, and that negative 1/2, then we minus 1 off that, and so that'll be negative 3 over 2. All right, so there's my derivative, and then it's just a matter of cleaning up. Okay, so we've got negative 1/4 times by negative 1/2, so that'll be positive 1/8. So I'll do my numbers here, 1/8. And then we've got x to the negative 3 over 2 on the top line, and x to the negative 1/2 on the bottom line. Okay, so just doing a bit of cleaning, and we can simplify that because there's x, so we just need to subtract those powers. So let's do that. So that's 1/8 let's subtract those powers. So this is negative, I'm just writing it over here, negative 3 over 2, take away negative half. So let's just be careful what's happening here. So that double negative there becomes a plus, and so negative 3 on 2 plus 1 over 2 is negative 2 on 2, or negative 1. So that'll be x to the power negative 1 there, which is equal to, let's put it here, which is equal to 1 over 8x. Okay, that x goes to that bottom line, and that's our derivative. Now, that's one way you could do this question, but I'll just show you another sort of method. I'll do that in red over here. Another method here. Okay, so just going from that over there, let's just rewrite this. If you remember, one of our log laws is that you can take that power down the front. Okay, remember that log law, that you can take that down the front. So this is actually equal to negative 1/4 times negative half log ex. That was one of our log laws. You can just take the power, if it's inside the log e function, you can take that power down the front, and Bob's your uncle. Okay, and so multiply those fractions together, and we get 1/8 log ex. Now it's really easy to find the derivative of that. That's just 1/8. The derivative of log ex is 1 over x, so that's just 1 over 8x. Okay, so that's just a nice little shortcut there. If you remember that log law, makes your life a little bit easy. You don't have to do as many horrible fractional sort of things. So that's a good little example there. Last one, let's have a look at this function. Again, we've got a function inside of the log function. So let's think carefully about this. Our derivative f dash of x is equal to, that 2 just sits there. Okay, I'm just going to put that 2 and forget about it. It's 2 times whatever the derivative of the rest of it is. It's 1 over that inside function, so cos x goes here. And then we need to times it by the derivative of that cos x function. The derivative of cos x is negative sin x, and that's everything I need to do. And so we've got negative 2 sin x over cos x. Okay, that's all it is. Hopefully you see that sin x over cos x is tan x, and so that's equal to negative 2 tan x, which is our most simplified solution we can get. Hope that makes sense. See you in the next video.